Some, sometimes it goes on automatically and I forget to shut it off.
Oh, right on. Oh, I guess I should have looked in the corner. Probably would have had the icon.
Yeah, me too. It's a big screen. It's way over in the little corner.
I know, right?
So let's see, what do we got so far? We got 12. Colby and Kevin and Ryder, Miguel. Dylan, are you outside? No, not Dylan. Michael. Looks like he's out. Are you outside?
Yeah, I'm actually golfing right now.
That's great.
No, but I'm there. I'm there. Don't worry. I'm gonna listen.
Okay, that's cool. Hey, there she is. Yeah, yeah. Hi. Make allow to. Oh, don't allow to multi-pin. Sorry. I think you're okay. What do you think? Are you oh, there's Katie. Lindsay, I think I unpinned you originally and then I put it back by accident. Okay.
Yes, I'm good. Thank you.
Okay, great. So we'll get Katie here. Allow to multi-pin. Okay, I think that's good. I've got Hugo pinned. Okay. So what do we got? 15, that's pretty good. How's everybody doing? Hey, Michael, are you just starting your game or are you halfway through it?
No, we're almost done. So
Oh, how you doing?
yeah, we're
Not
not
like shit on the
not
start.
not too good. Not too good. Not too good.
Yeah, that happens.
Yeah, I'm not too good at golf, but I like playing.
Okay, well, 6:03, we can start. We've got most people here. I have no idea who's still here. Let me check the roll. Oh, yeah, the roll shows, let's see, 1, 2, 3, 4, 5, 6, 7. Now the row shows about 19, 18 or 19, so we're pretty close. Oh yeah, okay. So tonight, mechanical, electrical, plumbing, HVAC. And then we've got next week is commercial and remodel. And then the week after that is final prep, and we'll do something as well, like written specifications. I don't know why I keep them till last, but I did. And then we do the final, and then we have the final review. So we're wrapping up here. Okay, so no, there's Duke. Yeah, 17. We're getting pretty close. So go to your Canvas file. Well, anyway, I've got on your Canvas file, I've got the handouts for tonight. Oh, darn it. So is everybody ready to dig in? Okay, can you see this? Can you see this file?
Yes.
Okay,
Yep.
great. So I think so if you go to set 11, 12, and 13, we're going to talk about tonight. And then 14 and 15 are next week's files. But so we're going to talk about first electrical prints, and then we're going to talk about plumbing prints, and then HVAC prints, heating, ventilating, and conditioning, air conditioning. So this book that I'm taking these from likes to give everybody a little terminology, but you don't really, if you're a carpenter, you don't really need to know this that much, because if you're doing your own electrical, some contractors, let me put it this way, a contractor by law is able to do electrical and plumbing in their project if it's a residential project. Like Jim Cunningham, one of the other teachers, he does his own electrical and plumbing. So in that case, if you were a building contractor, you might want to know this stuff a little more than just a carpenter working for a company. But so electricity has a couple of terms in terms of its power. So you've probably heard of amperes and certain amp fuses. So they use metaphors for electricity from water. So here you have the measurement of the current. Current's a term for water, right? You have a current running down a stream or in the ocean. So when they started understanding electricity, they had to find some kind of metaphor that would give people a picture of what was going on. The truth is there's no real good picture. It's kind of a mysterious phenomenon, but they've settled on current and water terms to help people. So an ampere is the unit of measurement. So that's the amount of current through a conductor. We're talking, all this is stuff going through a conductor or an electrical line. Voltage is the next term, and that's the force that pushes that current through. Just like water, there's a force that pushes water through a pipe, and then watt is just a term that is the product of voltage and amperage. So when you so volts are defined in a certain quantitative way, and so are amperes. And when you multiply them together, you get a watt. So a watt is just a measurement of electrical power. It's just kind of the summation of these two forces. So current or amps times the voltage equals watts. So electricians use these three terms and the relationship all the time, because they have to figure out amperage when they just know the wattage, or they have to figure out voltage. Some of it has to do with safety. Some of it has to do with how much current an appliance at the end will take, how much current you can put through one circuit. So those things an electrician has to know, but carpenters don't really need to know that much. So a circuit, and some of you probably know this stuff already. If you've studied on your own or you've done electrical work, then you know all this. So let me just hurry through it. A circuit is, it's a, how can we say it? It's a road for electricity, and it's got at least two conductors, one going and one coming. And what electricity does is it starts at a source. In our houses, it's usually, coming from the utility company. It goes to our circuit box, and we'll look at these things in a second. And then each circuit sends electricity out, and that electricity performs a function when it goes through a light filament or it goes through an outlet and is used by something that's plugged in. And then it keeps going. It goes through those places where it is used, and then it keeps going and back to the source. So it's a continuous circuit. And there's two kinds of circuit, which they don't mention here, two kinds of electricity. There's DC and AC, right? And I'll write that on the board in a bit. But AC, alternating current, is the kind of current we use from the utility company. So when they first started creating electricity, they figured out a way, actually Tesla, the guy the cars are named after, he figured out a way to make an alternating current, which was more efficient. It could travel better than direct current. Direct current loses a lot of its force over distance. So a battery, like your car battery or any battery, is a DC, direct current. So they early on, they decided that they would make all the utility companies and the major infrastructure for AC electricity. But DC has come back because solar panels create DC electricity. So that has to be converted to AC to be used in your house. We'll talk about that later. So anyway, that's your basic circuit. Two or more conductors or wires carrying electricity from the source, which in a house is its distribution panel, to an electrical device like a light or a switch or a outlet, and then back to the source. So that's a circuit. You know, circuit goes and comes back. That comes from circle, right? Circuit breaker is just a switch that stops that circuit. And you can stop it automatically by pushing the breaker to off, like if you want to shut off electricity to do some repairs. Or if the electricity gets too overloaded, it'll automatically shut off. Conductor is any material that carries electricity. Conduit is just circuits that are enclosed. Not only are they in wires, but those wires are in some kind of pipe. And it's usually because that electrical circuit is exposed. For some reason, it's on the outside of a wall. So you have to protect people from it. So you put it in a pipe, in a conduit. Oh. I was adjusting my screen. And we lost the, oh no. Got to go back, hold on. So far, so good, everybody understanding this? Is that a yes?
Yes, sorry, I was muted.
Yeah.
Yep. Okay. Service entrance is where the utility from the utility or power station nearest you comes down the utility poles to your house. And where it attaches to your house is called a service entrance. And there's a service head, that little bent pipe that accepts it. And that brings it down to a distribution panel. We'll look at a picture of all that in a second. Yes, question.
A little bit blurry, just to let you know.
Oh, really?
Yeah.
This second page is blurry too?
It's a little clearer, but it's still slightly blurry.
Huh.
There you go. I mean, it's pretty good. You can read it.
Okay, okay. I'm not sure I can do anything about it, so I hope. we
Yeah,
can
no,
get-
that one's legible.
Okay, okay, super. Okay, so for building, I'll name the things that are really useful for non-electricians to know. So ground fault circuit interrupters, these are a special type of outlet and they use them where there's water. So bathrooms on the drain boards have to have them. Kitchens on the countertops have to have them. Anywhere where water is likely to be splashed on them. So here it tells where they're used mostly. And if there's some kind of fault in the current, like if water goes in there, it'll provide a place for the current to go, not in its regular circuit. And that could be going toward you. You know, you could short circuit that yourself with your finger if there was water nearby. So when it when it starts to get short circuiting, it sends a message in it to its interrupter and it shuts off in 25 to 30 milliseconds. So that's pretty fast. That's way fast enough to keep you from getting electrocuted. So it's really nice to have these around in your kitchen. So if you know water gets splashed on it while you're doing your toasting your bread, you won't get electrocuted from that. So that's a great invention they have. Now, if you short circuit a circuit in your kitchen countertop where the blender or the toaster is, if it gets a signal, like if you didn't have a ground fault circuit interrupter but a regular outlet and you splashed water on that, it would shut off at the panel. You know, that particular circuit that had that outlet would shut off at the service panel, but it would take a lot longer to do that. So in that time, you might get hurt. So they've put these circuit breakers not where all the circuits are in your circuit panel where the electricity comes in, but in the actual place where they're being used where water is. Okay, now electrical symbols we'll look at in a second. There's a whole page of them. So electrical print. So we're talking about blueprints because that's what this class is about. So this paragraph says there are several different types of drawings used to detail the electrical portion of a project. On small projects, few, if any, of the drawings are needed. So typically you'll just have stuff on your floor plan if it's a simple house. If you're a wealthy person and you have a lot of strange electrical devices that are complicated and draw different kinds of electricity, you might need a plan. But in most of our middle class houses, there's not much more than a floor plan, and we'll show you that in a second. So the main thing an electrical plan would show would be the distribution panel. That's your box in your house where all the panels are listed, all the circuit panels. Receptacles, which are outlets, switches, turn the outlets on, and light. Sometimes light fixtures are, fascinated to the ceiling or wall. And then they have broken lines that show how the switches are connected to the outlets and the lights. And those are the basics of an electrical plan, and you can get all of that stuff on the floor plan. There's enough room. So unless it's super complicated, it'll just be the floor plan. Otherwise, it might be an extra plan if there's complications. We'll look at if you remember the Laguna Blanca school blueprint, which we'll look at later. They were redoing an arts building. So it had lighting for drama and theater, and then it had art studios. So there was a lot of lighting and outlets that were needed. So they had a special plan for it. But that's a commercial or school construction. Okay, so let's look at some of these wiring diagrams. they may do drawings, like I said, if the wiring's complicated and you can't show it on a floor plan, there may be supplemental plans. So we'll look at some of those coming up. So these are your basic symbols, and we'll look at how these are used on a floor plan in a second. Sometimes in the middle of the room, this is becoming less and less popular. They used to put a light in the center of a living room or dining room, and you could have a chandelier come down over your table or whatever, and that would be switched at whatever way you came into the room. But now they're doing a lot of things besides just that ceiling outlet. There's a fan outlet symbol. Usually they have the letter that has to do with the symbol. So F for fan, J for junction box. So here's lighting outlet. They call them outlets because you put the fixture, you plug the fixture into the outlet like you plug a device into a receptacle. The receptacles, duplex just means they're two. You've seen that in your house, one on top of the other, two outlet receptacles. If it's a GFCI, we just talked about, you have to write that next to it to distinguish it. If it's outside, it needs to be a weatherproof receptacle. It has a box to protect it from rain. There's triplex and quadruplex outlets. We don't see a lot of those these days. Here's duplex receptacle outlet, split wired. So we'll take a look at this later, but say you had a switch when you go into your living room. You go in the front door. For a lot of us, we don't have an entry. We just go right into the living room. So there's a switch there. And sometimes you don't have an overhead light, but you might have a lamp on a table that lights up the room. So when you switch on the light, the switch services the outlet where that light's plugged into, and the light on the outlet goes on. Well, sometimes they want other electrical availability in that same area. So one of the outlets, like the top one, will be worked by the switch. And one of them will just be on all the time, like a normal outlet. So these are very useful, but they have a real specific purpose. Range outlet for a cooking range. So that's going to have an R next to it. It's got 3 lines. Clock hanger receptacle. I don't know what that is. Yeah. Now, this book that this came from was probably made 20, 30 years ago, and there's been a lot of new electrical gadgets. So, there may be some differences and there may be new symbols for things. So, and then there's switches. That's the third category. Single pole switch means just there's one switch on that little place. Sometimes there will be 2 switches above and below each other. A 3-way switch doesn't mean there's 3 switches on the switch itself, but it means that the switch is operating. There's another switch that operates with the switch. So if it's a room that you want to be able to shut things off from several directions, you would have a 3-way switch, or a 4-way would have 3 places to switch it off. We'll when we look at the floor plan, we'll look at those. Those are the main ones, okay? Now, I don't know why they have television outlet. Well, maybe because it's designated out and they want a lot of power and they don't want anything else on it. So that may be why they put TV. But now TVs are getting more unique, and so they may require other electrical demands. Although I got my first big screen TV a couple years ago, I was kind of late, and it required it. You could just plug it right into a regular outlet. So I think they figured out how to make all these appliances pretty normal.
I think that's for the coax cable, Patrick.
The television outlet?
Yeah, for the wall, for the cable.
Yeah, maybe. Well, that's what I'm saying. Cable may have their own, since the advent of cables, they may, computer and television cables, they may have their own symbols too. Yeah. Okay. So then here's the a residential electric plan. Now, it's called a floor plan. So they should say a residential electrical plan on the floor plan. Remember, because we said you don't always need a separate electrical plan. So this is a typical floor plan, and that probably could be bigger, right?
Yeah, yeah.
Is that big enough or more?
Can you zoom in a little more,
No, the plus stopped.
please?
It just stopped. I couldn't go anymore. So we've got some blueprints that we're going to look at that are I think are clearer, and so we'll look at this stuff again. But let's just show. So this there's something about this print. I had trouble with it too, and I read these things all the time. There's something not quite right about it, but anyway, let's find the front door. Where is that thing? Here's the garage. This must be the front door here. Yeah. Yeah, here's a porch. So do you see where my arrow is? Everybody?
Yes.
Okay. So you come in the door and your house is dark because you've been out to dinner and you shut the lights off. So here's the switch. So you switch this and it switches on this outlet. So this living room doesn't have a light in the middle of it. If you go up here for the all-purpose room here and the dining room here, they have lights on the ceiling. So sometimes the switch, here's a switch coming in from this. You come into the living room and you go into the dining room and you can hit the dining room overhead light. Living room doesn't have it. So what they've done is they've switched one of these outlets, and that will probably have a table with a lamp on it. But it shows this going to another switch by the dining room in case you're coming from the kitchen and you want to go look at TV and have a drink in the living room and it's dark, and you just walk over to here and here, and it's the same switch. It'll switch this light on. And if you're coming from the bedrooms area, there's a switch here. So you don't have to walk all the way across the room, down to here or over to here, because you might bump into stuff in the living room, furniture. So they usually put big rooms that are full of things that you'll hit in the dark. They usually multi-switch them. Yeah. Other rooms like this is an all-purpose room. It has a switch when you're coming from the outside, so you can hit it real quick. And then if you're coming from the hallway where the bedrooms are, you can hit it from there.
Hey,
So
Patrick,
Yes, sir.
does tying the electrical outlets like that invert the switches? Say you turned the light on when you walked in the front door.
Yes. Yeah, it'll change
and then you're in the kitchen and you like want to turn the
Yeah.
light off.
Right. So when you use another one, it changes the polarization. So the switch will be where it's usually off. That'll be the on position.
Gotcha.
At least that's my experience. If there's any electricians here.
Yeah, I have an experience like that at my house. So I was just curious.
Now, some genius may have figured out a way to make that not happen, but it would probably cost you a lot more money for the switches. They can do anything, but it's just, that's the simplest way.
Yeah.
And the same thing with the garage. The garage has several pole switches and they're going to 2 lights. So that's the main thing. We'll look at a floor plan that of our own stuff. pretty soon and you can look at the different rooms. But, you know, here's a bathroom. You go in and there's a light there's a central light. There's small rooms, so they only need one overhead light. But there's a second switch for mirror lights, right? They're probably makeup lights maybe for over the sink. So you can kind of tell what all this stuff is and how, and you know, where people are used to putting switches for them to be handy. Okay, we're moving on. So this is a picture. Geez, I must have been high when I put these in the printer. Look at the angle. So high on life, right? So this is some kind of evaporative cooler, and it requires special wiring. So they may do a whole page or this, you know, it depends on whether they thought of it when they were designing the house or not. If the architect had it, he could put this in a detail page, right, where other details are. They could have a whole page of electrical or HVAC details. Or if they, you know, they asked the plumber to come up with one to put in the plans, it could be just a page that's stuck in there. But so sometimes they need specialization there. So this is getting back. I might as well keep it zoomed up here so we can read it easier. So these are all names for a circuit breaker box, a lighting panel, power panel, breaker panel, or distribution panel. Those are all alternate names. But it's basically, we'll show a picture of it, but you all have one in your house. It's just a big, you know, 2 foot across, 2 foot, 2.5 foot high box with a bunch of circuit breakers in it. There used to be a box with fuses, right? The round fuses that you plug in, you screw in. But every time, if a circuit overloaded and too much power went back to the fuse, the fuses were made so they had a little filament in them that would burn if the amperage was too high. So if you somehow it overloaded a circuit, it would burn the fuse out and you'd have to replace the fuse. So you can imagine how tedious that was, and people would never have the right fuses in hand, right? They'd use them and forget to go get new ones. So people would put pennies in the fuses. A penny will also span will let the circuit go. It'll span where the fuse breaks it. But what's wrong with just putting a penny where a fuse was? Anybody?
Fire hazard?
Fire hazard, yeah. You know, the fuse, the filament would break and then that would shut off the current. But a penny would just keep heating up and allowing the current to go. So
They basically bypassed it.
it basically bypassed it. So it wasn't a safe thing. People did it. People didn't know, or they just did it couldn't have any choice for that moment. And then somebody came up with a circuit breaker, which is a much better thing because you don't have to replace fuses. The breaker just goes off. You turn it back on. If it keeps going off, it means you haven't eliminated the short in the circuit somewhere. But, you know, and you can add breakers to it, you know, and you can double up the voltage on them. And so a panel is much more, circuit breaker panel is much more convenient. Okay, lighting schedule. So when you see the word schedule, it's the same. Remember we talked about schedule in the beginning, that it's actually a list. Why they call it a schedule, I don't know. Because schedule usually involves time, right? So, but this doesn't. This is just a list. So lighting's just like a door or window schedule. It lists all the fixtures, you know, what they are, if they take any extra power or anything like that. There is one in here. So this is a sketch of a circuit breaker, a panel, distribution panel. And what they do is look at this. So you'll have rooms. Where are they? Oh yeah, here we go. So living room, these are lighting and receptacles in the living room. That's this circuit. There's a second circuit. There's a circuit for the garage and the kitchen. They're on one circuit. There's another circuit for the garage, which has hall lights. So they divide up all the needs of the house into circuits that, you know, go around and service the outlets and lights. But the way they do it, partly it's convenience. So they'll take rooms that are next to each other, but it's also partly the amount of energy they need. So if you have a dryer, which takes a lot of energy when it starts up, washers used to take more energy than they do now. Electric range will take good energy. Toasters take a lot of startup energy, even though they don't, you know, they only go on for a minute. Sometimes they'll put individual circuits, or they'll do a kitchen circuit and they'll have a couple of things like where a toaster is going to be, or a microwave, and they'll make those separate circuits so nothing competes. If you have a bunch of appliances on at the same time, it won't pop the circuit. So those are the kind of decisions that go into what's on the circuits, what kind of, you know, where they are, and see, what are these? Circuit description. Anyway. Then they might have an equipment schedule, like a lighting schedule, but that's if you have equipment that's going to take, that has unusual power needs and wiring differences. Then they have a thing called a one-line diagram, which we'll look at in a second. It's just a way they, that electrical circuits can be drawn. Here again, it defines circuit, the path of electricity from a source. In most of our cases, it's from the utility company, unless we're running on solar, which more and more of us are. And then we may still have a panel to feed the electricity back into and to use at night, or we may have batteries and be totally off the grid. So, and then they go through the components, that is the outlets and the lights, and then they come back to the source. So here's a one-line diagram, which means there's no depth to it. You know, they don't draw thickness of things or depth of things. They're just lines that show the way electricity moves. I don't know what this, I can't even tell you what this is of. You know, what kind of building or room this is. Anyway, that's what they look like though. And
This is a section, right? Is that a
what?
section? Is it like a section or elevation? I mean, or
No, this is like well, I think it's a plan.
it says,
Even though-
I saw the 4-inch raised concrete pad, and so
Yeah, that's a section, and these are vertical too because they're panels. But I think the wiring is not necessarily, you know, they're just they're connecting devices with wires. So, you know, the orientation in the room is not important. That's what one line means. So they can draw them different ways, whatever is the easiest to identify. So you don't want to draw a panel as on its end because you'd have this little thin line. It would be stupid.
right.
But with everything else, you can do that. So yeah, good question though. Let's see. So here's branch circuits are the various circuits you have. General lighting circuits are used primarily for lighting and outlets that are going to service small things like clocks and radios and TV sets, you know. So your house will have circuits of these. Then they'll have, like we said, they'll have kitchen appliances, which take more energy. So they'll have a different circuit, maybe several circuits, maybe some of these like your, I think they want microwaves on a single designated circuit without sharing with other things. But a lot of these like toasters and waffle irons and mixers, they can go on. But the thing is, they have to figure out how the average person is going to use the house. If you're wealthy and you're designing this house to the very way you live, you could say, well, yeah, I have parties in the morning and sometimes we're cooking waffles and serving toast and mixing drinks or whatever, smoothies, let's say. And they could be all on at the same time. So they'll say, yeah, we'll need a couple of circuits, separate circuits, so we don't overload it. So most of the time they just figure people will use maybe a couple of these at the most. So they'll, load them up a little more densely on the circuit. Yeah, here's individual appliance circuits. So sometimes ovens, washers, even refrigerators sometimes have just their own single designated circuit. Calculations, we don't have to look at that. And electricians do all that. There's a national electric code. The architect has to make sure, and his designers, his engineers have to make sure everything's going according to this national electric code. I'm not sure how strong. Somewhere I read that this was a suggestive code. What's the word I'm looking for? That it suggests you go along with this. But I think state and local codes are pretty fixed. They don't, they're going to be at least as strong as this, as a national code or stronger. Okay, conductor wire sizes, we don't need to know too much about that. That page didn't have much. Here's another set of plans. This is from another book. That's a mess, isn't it? So on a floor plan, we will look at floor plans in a minute. They often don't connect the outlets to the switch. In other words, this shows all the circuits and it labels them. Here's the first circuit. And then it has here a circuit schedule. So circuit 1 has the bedroom 1 and 2, these two on it. So say the power comes in at the switch here, then it goes to this outlet and it goes to the overhead light and it goes to these outlets, goes through the wall to this outlet, back to the light and back to this switch or vice versa. And then these switches have to be connected to the main panel some way. They don't show in the wall where these go, and usually they don't show the connection of the outlets. This is actually defining the circuit. So all the electrician has to do is just make sure these are in the wall instead of out here. But this tells where they would go. But usually they just put the switch going to a light and going to an outlet if the switch powers that outlet. Otherwise, the outlets are just freestanding with no connection. And the electrician comes in and they know how to do this. They could see a floor plan with just where the switches are. They need to know that so they can put them in place, where the outlets are to put them in place. And they'll take care of where the circuits go, the number of circuits, what they service. They do that on their own. In a normal house, the architect doesn't pretend to be able to do that for the electrician. And this has a lighting fixture schedule too. So for circuit 1, which is the 2 bedrooms, it has there are 2 type A, and then somewhere it'll explain what type A are. They're a certain kind of ceiling lamp, whatever. They don't fill out the schedule more, but that's what it would look like. And then you'd explain what each of them are. A would be this type of lamp, B would be this type of lamp, etc.
Patrick, I got a question.
Yes.
So for those 2 bedrooms, there's a switch that controls so if you're walking in the bedroom one and you flip that switch on, that's gonna control all the outlets and the light? Why is
No, no, what it does, it means it's making a pathway to the light and to the outlets. The
Oh.
pathway to the light will light up the light when the electricity goes through,
Right.
but electricity will also go through
If it's
past
off.
the light
Okay.
and go to the, and just make these outlets available to be used. If they had a part dark, like we saw in the symbol, if the one side of the circle was filled in dark, that would mean that the switch actually
Control the outlet.
made it live, and you could have like a desk lamp there that would light up when you turn on the switch.
But because they're all connected, so that's one, like you have that on one breaker, for example, like.
Yes, yeah,
Okay.
it's probably, well, they say circuit one, so that would be a single breaker.
Okay.
Yeah, each of these 8 circuits would be a breaker.
Breaker. Okay.
Yeah.
That answers my question.
Yeah. So this shows you a little bit more. But like I said, the difference between this and the last one and the floor plans we're going to look at is usually they don't connect the outlets. They don't actually put the circuits themselves in.
And let the electrician figure it out, right?
Yeah, they know what to do. They go right to it. What they do want is they have to put the switch and light, because the client will look at the plans and say, okay, that's good. That's where I want the, sometimes they'll put a switch on the wrong side of the door. And the client will say, hey, I can't turn this on because the door's in the way. So then they change it, So part of it is information for the client to make sure it's the way they want it. And so that this is usually not here, the actual circuit connections. At least in my experience. Maybe some people do it. So let's see, anything else? Oh yeah. Okay, so here's I don't know what kind of drawing this is. It's probably computer generated, because no one in the right mind would try to draw this freehand. Look at it. I mean, it's a mess. But this shows the circuits also. Here's where they come into the house, and then it goes here, and one circuit goes to here, and then electricity goes this way, and this must be a porch light or something, goes over through a joist system, in that ceiling or floor of the next room, goes to here. Oh yeah, it goes over to here, and also goes across the house this way, and comes down and around and over to there and there to there to there. So that just shows you how they all, and here's a formula for how many outlets you can have, but we're not this class is not learning how to design, how many outlets you can put in. So, but now here's PV systems, which we should talk about just a little bit, because we're required to do this in all new houses now. So this is not a casual thing anymore. This is a mainstay of our lifestyle. So here's a good picture of the service entrance. Electricity comes from a telephone pole, right? Or it could be underground if the developer thought of it ahead of time. And those telephone poles go to transformers, and eventually they make their way back to the utility company, the plant that makes the electricity. And this is a wire that ties this. These have a cable that holds this up, and then the wires jump off and go into this. I forget what they call this little hook here. And this is all pipes. So they're protected. They come down to a meter, because the utility company wants to know how much electricity you're drawing so they can charge you. And then it goes into the house. Sometimes the electrical panels are on the back side of the wall with the meter. They probably put them here so you could see them. And then in a normal house, they just go to a distribution panel, and then they go to the various AC outlets and circuits. When you have solar, it changes a little bit. So solar, you can have with batteries and not use the utility at all, not have any electricity coming from the utility company. But you have to have batteries to do that because solar doesn't work at night, right? So your batteries aren't generating power, but the power they generated, the extra power they generated during the day, they powered everything that was operating during the day, and they also fed power to the battery pack. Then at night, or in a gloomy day, let's say it snows for a week, these batteries will have enough juice to keep powering the house for that time. When you size a array of solar panels and batteries, and you don't have any help from the utility company, you have to make sure that your batteries will provide you electricity under worse conditions. So you really do a lot of research. When I had my solar class, it was really interesting, the formulas they use for sizing these, because, you know, you can't, you only have enough electricity in your batteries that you get from the solar panels. You're not getting it from anywhere else. So you have to have the right amount of panels to charge the right amount of batteries to give you electricity for the worst case weather conditions. So the more in snow country and overcast country you live, you have to be really careful. So you have to look at weather maps for the past few years and find average time that, you know, the worst times that you may be without sun, basically. So that's a whole little science in itself. It's kind of fun to learn. Solar's got a lot of interesting things to learn. Anyway, the power comes from the solar, and it's DC power, direct current, because that's how solar cells work. They come down and there's always disconnects, but now they've combined the disconnects with the various things. So you won't always see a separate, but they really want a way to cut off that electricity. One of the reasons was when electrical workers have to work on power lines or transformers, or, you know, in a residential neighborhood, you know, they'll do a blackout. Like we've had several blackouts in the last few years. You guys all remember those? I think every place in Santa Barbara County has blackouts. Edison gives you notice and says, you know, from 9 o'clock Thursday night until 6 o'clock Friday morning, we're cutting electricity. You guys remember that?
Yeah, I remember that.
Yeah. So if these are cut, but they don't cut your solar panels because they don't control them. So your solar panels could still be generating electricity, putting it into the grid. And then when those poor guys are out there working, they're going to get electrocuted from your solar energy. So they had a device, and they used to depend on people to do this. And then they came up with a device that would automatically shut this off if the power from the meter was shut off. So now it's all automatic. They don't depend on people because they don't want to fry their workers. So, but that's why they originally had them, because it was really important to isolate solar created electricity from, you know, various things. So it's DC. We use AC in a house. So somehow it has to get from DC to AC. And there's a thing called an inverter. And that takes the DC and it turns it into AC. And when they started making them, they were about 60% effective. So you'd lose about 40% of your DC power. Now they're up in the high 90s. They've really perfected these. So it's you almost get the exact power from your DC as AC, which is really great. They call this a power conditioning unit rather than an inverter, because it also has I forget what it's called. It's a device that makes sure the electricity coming off your solar cells is in sync with your batteries. You know, there's different wavelengths, and the wavelengths vary for different reasons. And it'll screw up things if these have a slightly different wavelength than your battery. So they go through this device that makes sure it kind of gets the reading from the batteries, and then it makes sure these wavelengths are the same, and then it can feed the batteries to store. So this box has both a power conditioning unit and an inverter. It's a combination. And then it goes, and again, they have an on-off. They're really paranoid, so they have another on off switch, and then it goes back into your solar panel. So what happens is if you're connected to, say you don't have batteries, but you're just connected to the grid, the solar energy will go into your distribution panel and go out to all the things that are needed in your house. If there's any electricity left, if your house isn't drawing the same amount as coming in, that electricity will go on through to your meter and will go back to the utility company. So you're actually generating power for the utility company. When this first started happening, they refused to pay you for that power, but everywhere else in the world, they do that because it's ethical. So finally we convinced them, and now they will pay you for that. They'll give you credit for that back power, which led wealthy people in Montecito to have giant banks of panels in their backyard, and they would make more than enough energy for their house, and they would feed this tremendous amount back to the utilities and make money on it. That really ticked the utilities off, but I think they have a limit to it, but they can't stop it. So now they pay you the base rate, which is often not a fair amount, but that's as far as the fairness has gotten to this point. So, but the nice thing about the thing that really helped solar get started, this is such a beautiful thing, is somebody figured out originally solar had to go to batteries because we had they would use it at the time. And if you wanted to use it when it wasn't sunny, you had to go to batteries. Then some bright person said, hey, why don't we feed that electricity back into the system? And then at night, and then we'll give people credit. And then at night, when there's no solar being generated, they can use the regular electricity from the utility company, and we'll just charge them the difference. Whatever, if they had any credit from what they fed in, we'll subtract that from what they use at night, and everything will be even. So that allowed everybody to have all the energy they needed. You know, if they didn't plan right and they didn't quite have enough solar array, then they wouldn't go without electricity because they could just borrow it from the grid at that point. So a lot of people realized, well, the rate of electricity, you know, we have a rate system. So if you use a lot of electricity, you're charged more than if you use a little. So people said, well, we don't have enough room to have panels that will cover all of our electrical needs. So they said, but if we did just some, then that would mean that we wouldn't have to use a lot of electricity, and we could probably get on the lower rates. So people were doing panels to bring their electrical costs down because then they were using the lower rate costs, and they were saving money that way. So it was a win-win situation. You could always win having solar panels, even if they didn't cover all of your electrical needs. The problem is the grid. Is this interesting to you guys?
Something I didn't know.
Those of you who are
Yes.
awake, is this interesting?
Yes, it is.
Yeah.
Because, I mean, I wouldn't probably go into it this much, except that this is going to be required starting last year for every new house. You have to have a solar array. So you might as well get a little bit familiar with it.
That's required starting next year?
Yes, in California.
Wow.
For new residential
A
construction.
new residential has to have solar. And
Wow.
I think cannot have gas at
What
all.
percentage of solar?
Well, you can have wind. You can do a non-fossil fuel. You could have wind or what's it called? Geothermal, but those are more costly and you know, a little harder to do. I mean, for wind, you have to live in a wind zone.
You're saying
What do you
no
mean no gas?
gas?
No gas and no fossil fuel electricity.
I don't think
Oh,
that's passed.
not
yet.
natural gas.
I think it's in the works, but
Well, I know, I mean, I'll check because it changes all the time. I know you have to have electrical solar panels. I know that in the state of California, new construction. I don't know if the non-gas, the not allowing gas is plugged in yet. If it's not, it's getting ready to.
Solar, that's good though.
Like SoCal gas, like that? You're talking about that kind of gas?
Yeah, the natural gas that you power your stove with and your
Water.
furnaces.
So it's all gonna be electric now, or?
It's all going to be electric, because electric we can get from solar panels.
Okay, oh, wow, okay.
You know, that fossil fuel, it's still feeding the greenhouse gases that are causing the global warming. And there's no other way to get rid of it than to find an alternate power source. So people don't like it, but guys like Newsom, the governor, his staff that works on climate change, you know, they just, the whole world interchange, the scientists get together and talk about this stuff constantly. And they're saying that we have to be really radical to turn this around, to keep this from getting worse. We're already feeling the effects, and we will. But if we do nothing, the effects are going to be a lot more horrendous in 50 to 100 years. So we're trying to shave that off so they're not quite so bad. And the only way we can do that is to really stop using. And, you know, we started with voluntary because we thought people would be conscientious and do it. But for, you know, for all kinds of reasons, people weren't doing it fast enough on their own. So the government just stepped in. And, you know, a lot of people who don't like government intervention don't like that. But on the other hand, it's a world climate problem that's really eating us up. So, you know, that's what we're doing. The problem, the next problem is if we don't have a grid, because we're cutting down on fossil fuel, when we get rid of the last coal and oil plants and have no more grid, then what do we do at night for the solar panels? Anybody?
Batteries?
What?
Did you say batteries?
Batteries. That's it. Storage.
Wow.
So that's why Tesla's hustling to get this storage perfected, because that is the future. You know, once we get rid of fossil fuels, we won't have this external grid that helps us out. It's been a great beginning system because it allowed us to do a lot of solar all at once. So it really was a great idea and it's worked really well. But if we have to go off fossil fuel completely, which they're saying we will to make this work, then we've got to have battery storage of some kind. And everybody around the world is working crazy to get the best, most efficient, cheapest, safest storage. So there's a lot of technology activity going on around the world in labs around solar and wind and this whole issue. You know, they're trying to create technology fast enough so that we won't, you know, that our lifestyles won't have to change totally, you know, completely differently. So anyway, that's where we stand. I'll find out for sure about the gas. I'm sure about the solar, but I'll find. They have to have solar, but I'm not sure if they have to have enough solar to power the whole house. There may be a minimum limit, like 50% of your house, but that's going to change too. That'll be 100% because there's no we got to get rid of this. So there's no other way. I'll check those details out, but if it's not here, it's coming very soon. Now, there's another thing called geothermal that's not used a lot because it takes space. You have to drill pipes down in the ground quite a bit, 100 feet. That takes drilling. And there may be problems with water table and things. Or you can run it under the surface of the ground 5 feet, but run it laterally, horizontally. But then you need a lot of yard space to do that. So the geothermal hasn't taken off. It's mostly in the country where people have a lot of land around their homes. But it's a great thing because if you guys know what heat pumps are,
No.
well, it's like air conditioning. Air conditioning, the kind of air conditioning we have now, it draws heat. It draws heat from the air, and that heat they use or it'll draw cool from the air, either one. They run them as both heaters and air conditioners. And instead of heating up something with like electricity or gas, they take the heat that's in the air, if it's a a warm day, they can take that heat and they can reverse it and get cold from it for air conditioning, or vice versa in the winter for heating. So heat pumps work off the heat pumps that you can buy at Home Depot, they work off the air. They're air drawn heat pumps. And the difference in the air outside and the different and what you want inside, seasonally, they can capture that difference in heat, which is really ingenious. It took physics a long time to get to that point, but it's a really great system. The geothermal heat pumps that go into the ground because under 5 feet, the ground's between 50 and 70 degrees all year round. 50 degrees is a height. You know, if you're in a 50-degree house, it's cool. You're a little chilly, but you're not gonna freeze to death, right? Because it's got to go down to 40 and 30 to freeze. But the amount of heat you can get from 50 or 60 degrees is incredible. So these pipes go down into the ground and retrieve that heat and use it for heating. So we've got a lot of geothermal. Let's see if I guess I don't have a picture. This is the end of the road on this one. Somewhere else I'll have a picture. So, God, how did an hour go by?
Time flies.
So, do you want to take a break or do you want to try to get through this?
Well, how long is it gonna take to get through it if we don't take a break?
Well, that's the right question. I'll try to do it in an hour.
1 more hour?
Yeah. I could promise you an hour, and then if we don't finish, we just take it up next week.
We'll get down to 8.
Yeah, eight-ish. Hours a little after. Give me the 7 minutes. 8:07. It's up to you guys.
I can take a 10-minute break.
Sounds
Okay.
good.
Okay, but we'll still keep it down. I'll let you go earlier. So let's take a 10-minute break. 7:17. Yeah.
Cool.
You know, all it
Okay.
takes is one person to want to break, and I'm legally bound to do it, and I'm fine with that. Actually, we'll all probably appreciate it. I won't keep you much longer anyway, so don't worry about the length, okay?
Thanks,
So
Pat.
take 10 and come back.
Cool. Thanks, Pat.
Sure.
Thanks.
Yeah. Hello, Katie.
Hi. I got trigger happy and I hit the leave button instead of the video off button. Don't ask me how I did that since they're at opposite ends.
Oh, you don't have to explain that to me. I do it all the time. So you need your multi-pin, right?
I do, sir. And it was like my hand could feel how wrong it was, and I just kept going in. I dove off that right corner deep end.
So I want to tell you and Lindsay, and I'm going to tell the class too, but you know, when I'm just reading stuff, we're sharing a print, it's kind of hard to get it all, but I'm going to remind everybody that we have that final prep the week before, and I will tell them exactly what I want them to know in these areas. So right now it's just an overview. So I don't want you guys to worry about it too much.
Thank you.
I always think these mechanical prints don't take any time, but I always end up, they're so related to everything, how we live, you know?
Yeah.
Hey, Alec,
Hey, Patrick.
I got a guy in my morning class who's outside every morning. He has no other place to do it, so he sits outside in a lawn chair.
In your morning class?
Yeah. He's up in
What
the
class
hills.
do you teach in the mornings?
Well, it's a special class for back to work people to try to get people involved, interested in the construction trades.
Oh, cool.
Yeah.
He sits outside.
Yeah. I always ask him how the weather is where he is.
Nice. That's
Yeah.
cool. Nice.
I got another guy that when he turns on his camera, he's laying in bed and the curtain behind him's drawn. And I swear he just wakes up and turns on the thing because he's laying down right where he sleeps.
Hey, it's not gonna be like that for too much longer, so
Yeah.
you gotta enjoy it
Really.
while you can, I guess.
Yeah.
Did you hear that California's gonna pretty much reopen by June?
Yes, I'm hoping. I was sort of thinking they might because it's going really fast now.
They said they were
Vaccines.
gonna eliminate all the tier restrictions.
Yeah. Well, I've already got permission to do for this summer class to do one class as a lab at school, and I think I'm going to do all of it at school.
Nice.
Yeah.
So Rodney's class I saw is 2 days. Is it his also 3 days a week? It kind of looks
That-
like it on the
which
on
class?
the
Oh, the summer
the
two.
schedule. Yeah.
Yeah, I think. But they won't put it up there, on the website unless it matches the hours of the class. Sometimes I'll
Yeah,
turn in
'cause
some of the hours will be wrong and they'll tell me, they say that it doesn't compute. You need more class time. So there's either
Yeah,
a
'cause
third
they-
class or he's dreaming about a 6-hour long class.
Yeah, they have Rodney's class Tuesday, Wednesday, Thursday, 6 to
Oh,
6
three
to
days. Yeah. Okay.
9:45.
Yeah. Thursday.
Yeah, Tuesday, Wednesday, Thursday.
Oh, that's okay. Because he'll be using the shop because all his equipment's there. And I think we have I'm Monday, Wednesday, and Thursday. His is Wednesday and Thursday too?
Yeah, that's what it
But
says.
that won't matter because we're out in the I usually have it out in the patio where we can build the roofs. And then if we
Nice.
need any class time or board time, I go in the other classroom, so we won't conflict. Or else we'd have to Indian wrestle who got the shop each time,
Is do you guys ever use Steve's shop?
No.
at all?
You know, I started the class there, the program there.
Oh, really?
Yeah, 15, 16 years ago. And the problem was, I mean, I had to go somewhere right away. The problem was I had to put everything away so he could use it for his shop class.
Gotcha.
So we couldn't build anything that was, that carried over. So that I realized right away that wasn't going to work. So outside his room in the parking lot facing our place, I took the first 4 parking places and I built this 10-foot high frame with tarps over it in case it rained. And we did all of our work.
Oh, nice.
Oh God, and the wind would blow it. You got come after a weekend and it would be kind of lurching and water would be, man, it was just really. And then my vice president, I was working under a vice president at that time. I didn't have a dean. And he said that we could get some classrooms from the school in Carpinteria if we wanted them. I said, God, sign me up. I'll take as many as they have. And so we got 2 because everyone else found out and they all wanted classrooms too. So you've been to school, right, Alec? Or have you?
Yeah.
Okay.
Yeah, I have.
So we have the 2 classrooms and then a patio between them.
Yeah.
So I made him
I
leave a
wonder-
patio because I figured we could cover it at some point.
Was Rodney talking about working on those tiny houses at all over the summer, or
No.
no?
Well, oh yeah, maybe. Yeah. Oh yeah, that's right. No, maybe because he's got that cabinet class. Is it 114 or 115?
It's 115.
Oh yeah. Yeah, no, he'll probably work on that. That'd be cool. Yeah, he's been wanting to do that, so this would be a great time to do it. We've had people want to buy that as is because they can always find a carpenter to finish it.
Yeah.
And we've been really tempted, but we got it from money from a grant, from a grant. Yeah, grant. And so we didn't really need the payback money. So we decided to keep it as a teaching aid for another year or so. Okay. So I wanted to tell everybody, wow, we're up to 20. Yikes. I wanted to tell everybody, we're going over this kind of fast. And there's been a lot of great questions, so it's going a little slower and we're going off into detail in some areas. Have no fear, don't panic, because when the final comes up the week before, I'm going to do a prep and I'm going to tell you exactly the kinds of questions that'll be about electrical or about plumbing. There'll only be a handful and I'll tell you what areas those are going to be on. So you don't have to try to memorize all this stuff. Just kind of go with the flow. The book gives a little background. So I do that for electrical and plumbing, but you hardly even need it because you can read the plans without much training. But anyway, so let's go on and do the plumbing, and the HVAC's not so. HVAC, it's an old book and that's been changing more than, except for PEX and plumbing. It's been changing really fast. So what I have is not really that in date either. So let's at least get the plumbing done. So let me go to my. Okay, you all see the plumbing print and you all hear me?
Yep.
Yep.
Okay, great. So we can streamline this. You can also read this on your own if you're interested. You may have an interest in these particular trades. Yeah, I mean, it tells what stage. This is good for a carpenter to know because you have to work around the plumber. So, both they didn't mention it in the electrical chapter, which is also from the same book. It's funny, but you have to work with them because they're drilling holes in your studs. So they can't do it after you put the sheetrock up. So you've got to figure out a timing. So, you know, you don't have the sheetrockers come in until the plumbers and the electricians are done filling up your walls with their stuff. Also, they will often damage some of your structural integrity because they don't know. Sometimes they'll drill in the wrong places or this or that. So you have to kind of work together to make sure the house stays where it needs to be. So they have a rough in, and that's just, you know, obviously the utilities have to be brought to the house, to the site. And then if you're going to do a slab, you have to have them come up through the slab where they're going to be coming up through walls. So you might have gas lines, well, not for much longer, but gas lines, water lines, drain lines, and electrical lines. If they're underground, a lot of electricals, you know, from poles. So that has to come in, then they pour the slab around that, over that. And then, so all that work's got to be done, you know, ahead of time. And then after then you come in when the walls are up and you can finish putting your plumbing pipes to where they need to go. So basically 2 stages. And there's basically 2 systems. There's obviously a water distribution system where you get water for your use, clean water. And then there's a drain system. And there's also, you know, they always say just a distribution and a drain, but there's also gas, at least in the past. And they always would sort of tack that on at the end. But, you know, that used to be one of the major plumbing systems. So let's see what this says. So here's a floor plan. This is a commercial floor plan, as you can tell from all these bathrooms. And in the plumbing floor plans, it's the same as the electrical. They don't put where the pipes and the walls go or where you're going to have a main plumbing pipe that's going to branch off. They don't do that on the floor plan. They just put the fixtures, the toilets, the sinks, etc. And these pictures you can't see, so we don't have to cover them. Then the other thing with plumbing, one of the things is the materials of the pipes, what the pipes are made out of. Copper's been the water distribution pipe of choice because it's easy to work with. You know, you can sweat the joints, and it stays real clean, and you know the water flows through it pretty well. But we're running out of copper, and we use copper for electronics quite a bit still, right? It's the best conductor for electricity. So we use it in solid state and computer stuff, as well as, you know, all the Romex and all the, most of the electrical lines, copper. So it's kind of good that we started PEX, PEX, which is a plastic pipe for plumbing. It's a plastic pipe that isn't toxic. So we had to come up with polyethylene, which is the least toxic of the plastic pipes, and it's fine to drink water from it, and it bends. It's more flexible than most plumbing pipes. So that's really starting to take over copper. Copper is also becoming more expensive as it gets more scarce. So people still like to use copper. It's just kind of this piping of choice over the years, but I think it's probably slowly on its way out. They used to use steel pipe and galvanized so it wouldn't rust. And, you know, old houses, you'll see some of that, but that's not used a lot anymore. Maybe commercially, I don't know a lot about commercial plumbing. Brass pipe is used for various reasons. Sometimes the fixtures, you know, on plumbing, they won't make a copper version. It'll just be brass because for some reason, maybe because it won't corrode as much, maybe because it's a little stronger. Brass is a stronger metal than copper. But they don't, plastic pipe is used extensively. They're not even talking about PEX. This book was written kind of pre-PEX. And ABS is used as a drain line. That's the black plastic pipe. You see it at Home Depot. And PVC is the white plastic pipe. Neither of those are allowable for water distribution now because they slough off toxins. And so they don't want people drinking out of those. So you cannot use those. You can use them for drain because who cares what the drain water has. But you can use PEX plastic pipe. And there is, it may be polybutylene. There is one white plastic pipe that's still okay to use, but it's not PVC for sure, and it's not ABS. But people just start using PEX or stay with copper. Drain system, sometimes called drain DWV, drain waste vent, because the drain, well, they drain waste and they also need a vent as part of the system. So we'll look at that. So, you know, you can call it a disposal system or a DWV system. That's kind of the traditional. So in the plumbing system, you need cleanouts, and probably you've never seen those unless you are involved with plumbing, but they're little Ys that come off plumbing systems where you can stick a snake in and get to some areas. But people cover those up. I've seen them in apartment buildings covered up with sheetrocks or in a place you can't get to. So in America, buildings are often torn down before you even need to, before things get so bad that you need to use a clean out. So, but they're required. We'll look at where they go. We'll look at a drawing where they, a diagram where they're going to be. Let's see anything else before we get into the, oh yeah, the drain pipes in a bathroom. You know, you've got solid waste going down those pipes and a lot of sink and bathtub waste. They have to be big, especially for the solid waste. And so you need you can't do a 2x4 wall like in back of a toilet. It's not thick enough. Or you could use two 2x4 walls, but you can't use a single piece because they're, the pipes are often 4 inches and a 6-inch or a 2x4 is only 3.5, so it's not even big enough. A 6-inch has that little bit, it's 5.5, has 3/4 on each side, which will allow for joints and stuff. So you usually have to have a 2x6 wall behind a toilet. These are symbols, but I won't hold you for any of these because we don't really use them that much. This is a type of drawing, and almost always for a commercial building where they have a bunch of sinks and toilets and urinals lined up. And it's called isometric because it's at that 30-60, that 30-degree angle and vertical. And it just helps you kind of visualize where they're arranged with each other. I don't find it that easy. It's easier than maybe some other types of drawings. You know, the alternative is maybe a plan view from above, which would really be hell on this kind of thing. If you have multiple stories, a plan view is kind of useless. And then an elevation, which would be useless because everything would be behind everything else. So where things are lined up together, you kind of have to have this kind of drawing to show where they fall. But again, as a carpenter, you won't need to use this kind of drawing. Just the plumbers would use them. And then here's some pictures of plumbing systems. You know, they show a hot water tank. They show the piping, you know, that goes to the various uses of hot water. Yeah, you know, that just kind of gives you an idea. If these are some of the symbols that are used in here, but you know, you mostly can see just the way things are piped. So this is a water supply. This is the supply side. And then this is the drain side of the same house. And so it'll have the, you know, the drain from the bathtub. Notice the, let's see if I can get notice the little curve underneath all these fixtures. And that's what is that, a trap, right? Some of you heard the name trap.
E-trap.
Yeah, P-trap, or they have different kinds of traps. But every fixture that drains something has to have one of those. Does anybody know why?
Catch little heavier things that
Keep
you
the
might
sewer
not.
gas from coming up.
Yeah, well, that first answer, to catch things, is not its intended use, but it's turned out to be one of its uses. If you drop if your wife drops her diamond ring down there, often it'll settle on there and you can just take it apart and get it. So that's true. But it's intended to keep the gas from the gas will rise, and all these are slanted down so that the water drains, so the gas comes up on the same slant. And when it gets to here, it'll go laterally, and there's usually water in this trap because when water at the end of water pushes itself through until it gets to the end of it, and then a little bit sits in that trap. And that little bit of water that sits in that trap will keep the gas from coming up into your sink and into your bathroom or kitchen or whatever. And if you didn't have that trap, you'd know the smell. You'd get a sewer smell all the time. So these traps are mandatory. And everything connects one story to the next. It goes down to what's called a lateral in your yard, and then it connects to the street sewer system. Sometimes this pipe is usually a clay pipe, sometimes steel. Sometimes tree roots get down and break this pipe. So you might have to have some excavation and have a person come in and replace that. That happens occasionally. This is another, what's called the piping drawing, with just single lines. It's just a schematic, quick schematic, but it shows you where the drains go. And this may be just a drain section here. This is the same one in a schematic. When a house is got single appliances, like your bathroom only has one lavatory or sink and one toilet, or WC, they call them. You can show them side by side. Usually, if you looked at this coming from this direction, they might be in front of each other. So it might be a problem. That's when you go to something like this, because it's hard to get them in. They're always side by side when you have those two dimensions, but with this single dimension, some things may be hidden. So that's why they'll sometimes go to this. But usually houses are pretty simple. They don't need to do that. And this I just stuck on, when you get when you have a house built or an addition, or your kitchen's remodeled and you have a different sink put in, it's the plumber needs to have this. And often you'll just give him or he'll even buy the appliance. You'll tell him where you saw it and how to get it. And then he needs these to tell how far apart to make his stems for his handles. They have to connect to pipes. So they're spaced certain ways. It's not at all standard anymore. There's a couple of standards, but there's a lot of variation. And then the drains have to be spaced. This tells how they're spaced from the back of the sink, the center of that drain. And then it tells you how much you have to leave to the front of the counter. So this is all good information that the plumber needs to know. Also, if you're putting in like a granite countertop, the granite people would need to know this too, because they have to make holes for your appliance, for your fixtures. Okay, well, that was easy. I'll show you a PEX system when I get a picture of one. Have any of you worked with that?
No.
No, I don't think so.
Yeah, okay, great. They're red and blue plastic, very flexible plastic, and they usually come off of a, what do you call it? What's the word? They're all put together like a manifold.
Roll.
Yeah, well, they come in a roll, but they're put together in a manifold, and it's really kind of an ingenious system. And I think it's the wave of the future because, you can curve them, copper, you have to put, you have to sweat elbows, right, to make turns. So it's a lot of work. and they can leak. And with the PEX, it just bends. So you can just bend everything. So it eliminates all that work. So it's really a great system. You need a few special tools to work with it. Maybe I'll get those, but the reason I don't have them is because it's not really a blueprint issue, but some of you might be interested in it. Let's see, what time is it? Oh, we got a little time. Let's see what the HVAC says. So HVAC stands for heating, ventilating, and air conditioning. So those are the systems, and typically in Southern California and many places in the country, there is a forced air system where they have a big furnace that burns gas. My house it's a natural gas furnace. Sometimes it's they could be electrical, but they're usually gas because it's so much cheaper to heat with gas. And then they heat up. They take the air that's heated up, and they force that air with fans through ductwork all around your house, right? And you'll know if you have those because you'll have vents all top and bottom of your walls and ceilings. Now, I lived in New England for a while, and this may be true of a lot of the north of the country, is they have boilers instead of furnaces. So they boil up water, and then that water, they'll have baseboard pipes that have a decorative kind of cover to them that has little fins that spread the heat, and they just pump hot water around the perimeter of the house, all the rooms. And so a lot of places use boilers and will actually heat water up instead of just air, and use that hot water for various heating needs. But in Southern Cal, we're mostly a forced air system. There's been a lot of problems with vents. Ductwork. They've not put in properly, and it has to be balanced whenever you force air one direction and then have return air. The force has to be balanced, and sometimes those aren't right. A lot of problems with those. They require filters. If you have that system, you have a big filter opening somewhere. I have it in my hallway up on top, about a 2x2 grill, and you have to periodically get filters because the air in your attic that the furnace is heating up can have all kinds of stuff in it, including insulation fibers. So that filters it before it goes into the rest of the house. But it's not the greatest system. We've used it forever, so most of our houses have it. Heat pumps are a lot. The original heat pumps didn't have enough volume to go into a whole house, so it wasn't practical, but now they're much more powerful, and they can put them in one room. And if you have an open floor plan, you can get to a good part of your house. So maybe you need a couple, 3 at the most, and they're really cheap, and they don't need ductwork, and they just attach to the wall. Sometimes they go through the wall, and they'll go to a unit outside, but they're really the thing of the future because they're electrical. They don't need gas. They don't need ductwork. So I think we're heading that way. So HVAC, the big thing was sizing a forced air system for your house. And most HVAC people, there's the building code has gotten a bunch of this engineering society to make a handbook of all the ways that you size systems. It's called ASHRAE, is the engineering institution. And if they go by that book, they'll size things perfectly. But a lot of times they'll use rules of thumb. So if your house is kind of like the house they did before, they'll just slap in the same system. And it may not at all be the same. It may have different needs. It may be too big or too small. So that's been a problem throughout. And when you have these forced air systems, that's all eliminated. So I think it's, HVAC's no longer the mystery of how to size these and get them right. So it's going to change that trade quite a bit. Hydronic system is that baseboard heat. And you know, it's radiant heat. It's a hot pipe that gives off heat. So it's like a fireplace. It's really nice heat. I lived in Maine for 10 years, and I would either add them to my houses or I would have houses with them. Really nice heat.
In the commercial setting too, Patrick, there's those chillers,
Yeah,
kind of like what you said. So, you know,
Right.
those have plans too and stuff.
yeah, yeah. So,
Professor, we
Um,
have a hard time hearing what that commentary was. And can you fill us in again on hydronic?
oh, hydro, let's see, what is it? Hydronic, right? Yeah. Oh, here it is. You see it up there, hydronic heating system? So they, at least in Maine where I live, the state of Maine up in the north, we had
Can't actually see anything.
pardon?
Your
We
screen,
can't- we can't see anything.
You can't see anything?
No.
How long has that been? You guys. Ah. Yeah, it's hard if you can't see anything. Okay. Yeah, that was my fault, but you haven't lost out on anything. So here's do you see the middle here, hydronic heating system?
Yeah.
So that's what we're talking about. So like in Maine, I had in one house I lived in, I remodeled it, but it had a boiler in the basement, and that boiler I would connect copper pipe to it and run those copper pipes along the bottom of each wall on the room side of the wall. And they have these I might find a picture for you later, but they have these they're covered by this, you know, piece, so you can't see the pipe, and it's got fins in it, and then it's got this nice cover, and it all around the baseboards in your rooms has this, and just radiates the heat from the hot water. So it's radiant heat, which is nicer than, you know, convective heat, and it's real simple. It's a great thing. We just don't do it. It's not cold enough here to do it. They may do it up Northern California or up the coast. I don't know. But that's what that is, hydronic. And then of course they have electric radiant heating that they put under the floors and things. But then that's no longer a plumbing issue. That's, unless they use hot water, but now they're just using wires, I think. Anybody seen yeah, here it says, yeah, they can use wires, or they did use pipes of water under the floor. Let's go down to, oh, here's the radiant heating, a layout for a series loop hydronic heating system. So I don't know where the boiler, oh, here's the boiler. So the boiler just pumps it, and it goes along all the baseboards in the house. Kitchen, you don't need it. It just goes down the center of the room. And then it goes along the edge of the inside of the wall. You got to go through the walls. And it goes this way and back to the boiler. So this has like two systems. It goes through the bathrooms, through the bedroom, and back to the boiler. So this has two halves. Air filters. So that's about it. There's not a lot. Let's see, what do we got here? Oh yeah. So we don't use solar collecting panels on the roof and windows so much, but it's kind of coming back. But you can heat just air, just like you heat hot water in a solar hot water collector. You can actually heat air and use it for hot air, and somehow get it, you know, if you wanted to get it everywhere, it'd have to be a forced air system with ducts. But you don't just need a furnace to do that. You can do it from solar collectors. Yeah, this is forced air. It comes in at the bottom, the hot air rises, goes into a duct, goes back to the heater, the furnace gets heated up and blown back through. That's how a lot of our forced air units work. I have one in my house and I use it once a year. It's so uncold in Santa Barbara, I hardly ever need it. Here's the picture. I couldn't figure out where it was, the geothermal system. So they have pipes that go into the ground and they're filled with fluid. If it freezes, they probably put some kind of antifreeze in it so it won't freeze and break the pipes. Gathers all this heat from the ground, comes back, and then goes into an exchange. So you don't want that kind of toxic fluid, the antifreeze fluid in your system, obviously. So if it's heating, it won't matter. If they heated a hot water tank where you're going to use the water to drink or bathe, then you'd have to have an exchange system. But anyway, the gist is that you get this heat from the ground and it goes to a heat pump, which converts it, which extracts all the heat from there and fan blows it into the rest of the house. This is a air conditioning system, which works the same way as the heat pump. The heat pump kind of borrowed it from this. And a refrigerator works that way too, a little bit. Okay, so we're just about, we're done. Let me show, let's see, where am I? Okay, so I'm just gonna pull up a few plans in the few minutes we have left, okay? Some of our plans. Maybe I'll do our house, our kind of school plan. Get rid of that and see what. The problem is I don't know what the floor plan is. Is it 4? Foundation plan, damn. Let's try 5. Framing plan, God. Maybe 3. This is supposed to be an educational plan and they've got it all in the wrong order. Well, so much for education, huh? I'll be there. Have faith. Okay, somehow. Bingo. So you know what? I love this. I've got a floor plan here and it's got no electrical in it. God. Perfect. All that for nothing. Okay, well, we'll go to, let's see. Oh yeah, okay. Okay, let's zoom it in. I can't move it. Anyway, you can see the see this media room on the left?
Yeah.
So you can see the switch as you come in the door, and it just goes to that overhead light. And then you'll see the outlets posted on the floor. There's a certain amount of room they have to be no bigger between them. I forget what it is. It changes. At one point I thought it was 6 feet, but this is bigger than that. But so they don't show the circuit connecting these. Remember we were looking at that drawing? So this is more typical, not to show that. Just to show only the switches, light fixtures, and outlets. Okay. Let's go to Can you still see this screen?
Loading, yeah, it's loading.
Yeah, you can see it still though, right?
Yep.
Okay, here's a commercial plan. So it's got a new floor plan, which doesn't really show any electrical on this. And that's mainly because this is a studio art building, and so there's a lot of systems. So here's a reflected ceiling. This has outlets. You can see one there, or that's a light rather. There's a wall light there. So this has lights, and commercial plumbing plans, they have to be ADA approved in public buildings, and this is a school. So they have to show elevations and show the heights of all the fixtures, right? The toilet heights and the, for wheelchair use, toilet heights and sink heights and stuff. So you do get those extra kind of plans in public buildings, commercial public buildings. It's funny, this has one little mechanical section plan. So this has an HVAC system, and they're showing how it's stuck up there in the attic. This is a mechanical, so this should be heating systems. So look like this is a furnace here, and the piping, ducting. They have some schedules here with plumbing fixtures and plumbing equipment. Specifications, commercial and public buildings are a lot more spelled out because they can't afford to have any problems, or everybody sues everybody else. So this has its own plumbing floor plan. They probably put in a couple of extra bathrooms. This was an existing building, so they're kind of converting it. So let's look at close if we can see anything with this. No, it's not very clear, no matter how you look at it. So here's a circuit panel. Remember we saw that panel schedule, and then here's a lighting fixture schedule. And here's some more schedules on outlets and switches. And then here's a wiring diagram. Remember where we said if it was, this is a Douglas lighting control. It's a special kind of, unit commercial unit they have. So they have to show how it's wired. Then here's a line diagram again, no depth, just spacing things out and showing how they connect. There's a lot more that's in commercial building, especially this kind of building, because it is a studio, and so it's got all kinds of lighting and power and signal. Signal plans I don't know, is that anybody's signal plan, like if they had internet connections?
Not sure.
I think signal may come under that. And then there's another lighting plan. So a lot of detailed work because these have very specific things. And look at these indoor lighting schedule. Yeah, see, it's a whole nother world. I know, Marcos, you're the one that does more commercial work.
A little bit.
Yeah.
Depends on the signal stuff is the more IT stuff.
Yeah. Okay.
Yeah.
And then fire alarm plan, public buildings, they're really paranoid about fires hurting people. So they've got a whole plan for that. Here's another wiring diagram for, I guess it's part of the fire system. That's a lot of detail, huh?
We do a lot of fire big time in the schools.
Yeah. Yeah. So we're at 8:02. That's pretty good. So again, when the final comes around, which is not that far away, 3-4 weeks, I'll prep you guys for it. We won't do a lot on those plans because we're not plumbers or electricians or HVAC people. We're builders. So it's good to get an overview, and then I'll tell you the few questions from each of those we'll have in the final. What is the other stuff we learned this second half? Anybody remember?
Second half of the class?
Yeah. Wow. Well, that's going to be an interesting.
Electrical, plumbing, HVAC.
So we have written specifications. We'll talk a little bit about that. I'll show you some commercial plans. I have a book that has some stuff on Wendy's that's kind of interesting. Remodel. I'm not going to show you much of that. I'm going to talk about a little bit about things to watch out for that the plans don't cover. We did that estimation, some basic math, remember? So we'll go over that. And then using plans from construction prints. Yeah. We'll cover all that as a prep, so have no fear. So I'm done. Any questions?
Yes, sir.
So I would say we should go home and try to salvage our night. So I will see you next, what do we meet on Tuesday? Next Tuesday night.
And then Patrick,
We're winding down. So if you have, make sure you write down your questions if you have any, of your own. Don't worry about questions about what's going to be in the final, because like I said, I'm going to prep you for that. But if you think of something, you ask great questions. I love the questions you ask. They're really good. So it allows you to hear someone else besides me drone on. I was hoping we'd have more people that knew more about, commercial. I've always been a residential contractor and carpenter, so I really don't know very much about commercial. And our program doesn't teach it officially. I probably should have learned more over the years, but it's a huge, different area. Those of you who know a little bit about it, it's so different. And you need to start with this anyway. This has all the basics in residential. And then you just learn layers on top of that. So anyway, have a good week. Enjoy the good weather. Get your shots. Some of you are old enough to get shots, and they're going to come down to 16 and above and not too distant future. What?
I heard they already started it.
In parts of the country, I don't know if Santa Barbara County has. Maybe they have.
Specific to Santa Barbara County, but maybe I was.
Yeah, so it's coming. If it's not here now, it'll be here in a few weeks. So let's all get vaccinated and stay safe.
Sounds good to me.
We're almost to the end of this.
All right,
Okay,
man.
everybody.
See you next week.
All right, see you next week.
Patrick, thank you.
Yeah, thank you, guys. We'll see you soon.
Yeah.
All right.
Hey,
Bye-bye,
Patrick,
everybody.
you get to mark me as present. Patrick,
Oh, yeah.
yeah.
What did you ask?
Oh, I asked if I came in late, a couple 10 minutes. Did you get to mark me as present though?
No, I didn't even take roll, so I'll mark
Oh,
you.
okay.
Yeah.
Sounds good.
I kind of know who's here, but I'll get you, yeah.
Alrighty. Have a
So
good night.
remember to look at the video for anything you missed.
Yeah, of course. Of
Okay.
course.
I'll have
Thank
it
you.
up by, at the latest tomorrow, but probably tonight.
Okay.
All right. All right, everybody. See the rest of you. Good night.